So today we will look at the mechanism of enzyme action, right? So first model we have, which is lock and key model, right? So now let's discuss. Okay, first of all, who gave this model? Actually, this model was given. This model was given by Fisher in 1896. Okay, this was the model. This key element model was given by Emil Fisher in 1896. So, what according to this model, let me explain you here. Okay, according to this model, as a particular key has a particular key will only combine with a particular lock, right? That's like in the same manner, a particular substrate has a particular enzyme, and a particular substrate will combine with that particular enzyme, and then it will form the product. Likewise, according to this model, what is happening? Okay, according to this this model, particular substrate has particular enzyme, right? And the active site, like notice the active site, we see this region. This region, the active site is basically, according to this model, the active site is rigid. This active site is rigid. Okay, let me write here. The active site is rigid. The active site is rigid. Right? Now, okay. According to this model, enzymes are non-regulatory. Are non-regulatory. Now, what does that mean? It means that they are not regulated. What does that mean? That there is no and check and balance, check and balance on them. No one is there to see them. According to this model, enzymes are non-regulatory, no check and balance. Okay, for example, we are having lipase. Lipase is actually an enzyme, which is the example of this lock and key model. Okay, before moving ahead, I guess this model is clear to you, and the active site, the substrate is complementary to active site in shape and charge, both, right? The substrate is complementary to the active site in shape and charge, right? Okay, now let's move to another model, which is basically second model, which is known as induce fit model. Induce fit model, right? Okay, here we have the diagram too. Let me adjust this diagram over here. Okay, so I have adjusted this. So according to this model, basically, let me erase this one. Shit, by mistake, I removed this. Oh, here we have the diagram. Please over here. Oh my god. Sorry, I'm wasting out time. Okay, let's continue over here. Now, according to this model, when a substrate combines to an enzyme, it induces the shape of the active site. When the enzyme or when the substrate basically when the substrate combines with enzyme, it induces its active site. Now, what does that mean? It means that before and after the reaction, the shape, the you can say the shape of the active site will remain same, but during the reaction, it will change. Now, what does that mean? Or as you can see over here, enzyme slightly changes shape to fit the substrate. Now, what happens over here? Okay, you can see this in this diagram clearly. As you can see over here, the shape of the substrate is like this, and enzyme shape is like something like this. But what happens when the substrate comes near to this? The enzyme changes its size, its shape, and as you can see over here, it has changed. But when the product is released, the enzyme has recovered its side. It means that before and after the reaction, it means before and after the reaction, the active site is same, but during the reaction, the shape is changed. The shape is changed during the reaction, right? As you can see over here, I have shown you in the given diagram too. Okay, it means that the active site is flexible. Because it can change, right? The active site is flexible, right? Now, who was given this model? Actually, this model is given by Koshland. This model is given by Koshland, and according to this model, the enzymes are regulatory. It means there is proper check and balance on the enzymes on them, right? For example, we are having hexokinase, which is basically which is the enzyme which works on glucose, right? So the enzyme is hexokinase. Now, okay, one more thing I wanted to discuss. Yes, basically this model is like the first one model was known as lock and key model. This model is known as gloves in hand model. This model is known as gloves in hand model. So I hope this is clear to you. Okay, before moving ahead, there is one concept of active site that you guys must understand. Okay, active site basically there are two parts of active site, right? So number one is known as binding site. Number one is known as binding site, and number second is known as catalytic site, right? Okay, let me show you the diagram too. Okay, so here we have the diagram. Let me change this side. Okay, so as you can see in the given diagram, that means this. Okay, so basically this region, this region, this region, this region, this region. This region is known as binding site. Actually, it forms temporary bonds with them. Okay, or you can say hydrophobic interactions or hydrogen bonding with the binding site. The substrate forms hydrogen bonding or hydrophobic interactions with substrate on the binding site. But the site which actually catalyzes the reaction is known as catalytic site, and basically this particular region is known as catalytic site. This region. So this is known as catalytic site. Basically, the active site is made up of 2 to 12 or you can say 13 amino acids. In some books it is written that catalytic site is made up of 2 to 12 amino acids, but then like in federal it is written that active site is made up of 2 to 12 amino acids. So I hope this concept is clear to you. Thanks for watching.